Ladies and gentlemen, a very warm welcome to all of you. My name is Jeffrey Teo. On behalf of Park Systems, we would like to thank you for joining us today for the webinar entitled Park SmartScan, a point-and-click revolution in AFM imaging technology. So, before we begin, let me give you a quick overview of today's session. The presentation is expected to take approximately 30 to 15 minutes, which should allow us some time for a few questions at the end. So your microphone have been disabled by default to give our speaker an uninterrupted speaking experience. So moving right along, I would like to give you a short introduction on our speaker. Dr. Rocky Nguyen received his PhD degree in Mechanical and Automotive Engineering from the University of Aosan in South Korea, and his bachelor degree in Material Engineering from Bach Hoa University in Vietnam. So he's currently focused on the development and performance optimization of atomic force microscope and related techniques at Park System Korea. So without further ado, let us start the webinar. And if you have any questions, just feel free to type in the chat box, and we'll go through the questions at the end of the webinar. Thank you.
Hello everyone, this is Rocky from Park Systems. So throughout the previous webinar sessions, we have introduced you different AFM techniques from the very basics to the advanced measurement modes. On the other hand, to properly communicate with the AFM system and collect the high quality data, the AFM operating software is also very important. So in this webinar, I will be talking about the Park SmartScan AFM operation software, a simple point-and-click control for the AFM measurement. So the first part of this presentation will be the overview of the AFM and the AFM operating software. And then I will move on to the selling points of the Park SmartScan, including the auto mode, AdaptiveScan, True Non-Contact mode, and the step scan function. And the final part will be the demo session to give you a better vision on the software user interface. So as you know, AFM is a microscopy that can detect the atomic force between the atoms based on interaction between the tip and the sample. And using AFM, not only the surface morphology, but also various materials properties can be measured, such as the electrical, mechanical, magnetic, or the thermal properties. Normally, to collect the AFM image, we have to go through about 10 steps. Firstly, we need to set up the AFM tip and the sample. And then we need to put the tip into the system and align the laser onto the end of the cantilever. And after that, we need to adjust the offset of the beam spot on the photodetector. And the third step is finding the resonant frequency of the cantilever. And this including find the optimal rife frequency and the rife amplitude for the cantilever. And this is case by case different depending on the type of the cantilever you are using. And next, we need to lower the Z-state to bring the tip closer to the sample surface. And then we have to adjust the focus vision onto the sample surface so that we can find the region of interest by moving the XY stage of the AFM system. And the eighth step is approach the AFM tip onto the surface or just right above the surface. And usually this process is done by manually in the conventional AFM system. And next, we can perform a light scan to find the optimal scan parameter for the specific type of tip and sample. And finally, we can perform the scanning. However, you may need to repeat the steps 3 from step 9 to find the optimal quality for the image to meet the requirement of your research or study. However, the conventional software to control the AFM instrument often has the pretty complicated user interface. And also, you can see most of the scan parameter, like scan rate, the gain, drive frequency, drive amplitude, should be done by manually. And because of this, the using experience and the operation for the AFM instrument sometimes can be very complicated, and you should be trained by the skillful engineer to properly use the system. So in power system, we provide a new way to control the AFM instrument. I would like to introduce you the Park SmartScan software. So the SmartScan has the ultimate, which includes in 4 simple steps that can guide you throughout your AFM measurement. And similar to the point and shoot action when we are taking the photo using the digital camera. What you need to do is just click the button and the software will do the rest for you. So also the Park SmartScan offers the fast approach and easy to find area of interest onto the sample surface. And also we have the AdaptiveScan function, which can optimize the image quality in the shortest time. So let me explain in details about this automat. We have 4 major buttons: setup, position, image, and end. So when you click the setup button, a wizard guide will appear, and this will guide you through all the steps needed to set up the tip and assemble. From turn off the beam, unlock the door tab, and how to remove the head from the system, and then how to replace the FM tip, and how to align the laser onto the cantilever, and also including adjust the BSPD. And also this setup including how to guide on how to install the symbol onto the system in the proper location. And then when you click the position button, the automation will start. So you can monitor the positioning process from the optical view. At first, the system will automatically find the resonant frequency of the cantilever. And after that, it will bring the tip close to the sample surface and adjust the focus back to the sample surface so that you can find the position of interest. Then when you click the image button, the software will automatically obtain the AFM image depending on the scan parameter you set. So all you need to care about is the scan pixels, scan size, and the quality and speed factor. So this is related to the AdaptiveScan function. And I will be talking about details in the next slides. And when you are done with the scanning, you can click the end button, and the software will lift the tip far away from the sample surface and automatically turn off the laser beam so that you can uninstall or you can change another sample measurement. So throughout the 4th step, only the setup you need to do by manual. For the positions, image, and end, the software will automatically do the action for you. So about the AdaptiveScan function. This is a function to automatically control the scan speed based on the variation of the sample surface. In this example, this is the height along with the scan rate during the scanning. And you can see the AdaptiveScan function will vary the scan speed as the tip moves from the flat region to the valid region on the sample surface. So at the valid region, to increase the tracking performance of the tip, the AdaptiveScan will reduce the scan rate for the good tracking performance. And at the flat region, we don't really need the very slow scan speed, so we can increase the scan rate to reduce the time. And you can see from the scan rate image, during the scanning, the speed will vary from 0.2 to about 2 Hz. Comparing with the fixed rate scan, which is typically function in the conventional FM software. So using the AdaptiveScan function, A high quality image with good tracking performance of the tip can be accumulated during only 4 minutes. And if we want to get the similar quality image with the similar tracking performance in the fixed rate, we need to go like 0.2 Hz. And if we take 22 minutes roughly, which is about 5 times longer than the adaptive scan. And you may need to increase the scan rate to reduce the time. However, when we increase the fixed scan rate, the tracking performance is very poor. And you can see for the example as 0.5 Hz or 1 Hz. The scanning time, the total scanning time is roughly similar with adaptive scan, but the quality is not really good. So besides the adaptive scan function, to maintain the non-contact mode between the tip and the sample surface is also very important. This is to reduce damages to the tip and the sample surface. So in past system, we use the high-speed scanner feedback, and this high-speed feedback can perfectly maintain the true non-contact mode, although the scan rate is very high. In this example, we use the AFM tip to scan the sample surface in the non-contact mode at 10 Hz and continuously scanning for 3 days. And you can see the example on the polysilicon wafer. After 5,000 cycles, 10,000, or even 15,000, the surface roughness of the sample remains similar, and also so do the imaging quality. So this means that we can perfectly maintain the non-contact mode, non-contact status between the tip and the sample. And this non-contact mode is very useful when you want to measure deep trenches and the stick wall measurement sample. In this example, this is the new tip. Before the measurement and after taking 20 images, we still have the same quality, the same tip apex radius. If you are working with a large size sample such as the wafer, or you have to measure different area on the sample surface, you can use the step scan function. And this function allows you to measure the different area on the sample surface automatically. So this is like the upgraded version of the auto mode, and this will repeat the scan process according to the preset location you input on the sample surface. So when you run the step scan function, at first the approaching process in which the tip will be approached to the sample surface, and the scanning will be started automatically. And after scanning is finished, the tip will be lifted from the surface and will be moved to the next preset location. And this process will continuously looping until on the position we finish scanning. And also you can input the different scan mode, different method like NCM, contact, or even KBFM, EFM in different locations. So the only limitation here is the movement range of the XY stage of the system. So let me introduce you the SmartScan software. So we are looking at the interface of the SmartScan AFM operating software. So we have the different mode here for the auto mode, manual mode, and the other tabs for the maintenance of the system. And we have the vision windows here, scan area, scan traces, and the scan config. So in this demo, I will be presenting the auto mode, manual mode, and the step scan. So firstly, that will be the auto mode. So for the auto mode, all we need to care about is 4 buttons here: setup, precision, image, and end. So firstly, we need to set up the tip and the sample for the measurement. So I will select the prop, and the wizard guide will appear, and this will guide you through all the steps needed to set up the AFM tip and the sample. Okay. So we will click the next. Then what we need to do is just follow on the step. So I'm going to turn off the AFM beam switch. In the second, unlock the dovetails. Then remove the head from the system by sliding that to the right hand side. And next, we need to replace the AFM tip. So I have prepared already the mounted tip on the magnetic chip carrier. So put that into the magnetic rod end. Then put the head back to the system. Lock the dovetails and turn the beam back on. So the pop-up will appear and they will ask you to change the cantilever type. So yes, it's a new type. And I'm using AC160 cantilever. And the next is we need to change the focus to the cantilever. So we can just simply control the slide bar here. And also we can adjust the vision setting, the brightness, exposure, or the contrast for the clear vision on the cantilever. So is the cantilever in focus? Yes. If we click yes, the current location or focus on the cantilever will be marked in the software. Then we need to adjust the position, the beam, the laser beam to the end of the cantilever. Like this. And next, we need to align the SPD. So we are finishing with the tip setup. So I'm going to select the symbol setup. And similar, we just need to follow the guidance. Okay, so I have prepared the symbol, which is the LDD computer for the measurement. You see the symbol, and we just need to put that into the magnetic symbol holder. And make sure that you put the symbol in the center of the magnetic holder. Then just next. So we are finishing with the tip and the symbol setup. So I will close the pop-up window. Then we need to find the position on the symbol in which we want to measure. So click the position. Firstly, the system will find the resonant frequency of the cantilever. This is the automation process. So all we need to do is just wait for the system. And after finding the resonant frequency, which is about 378 kilohertz, the tip will be approached to the sample surface. And we can monitor this process from this vision window view. So if the vision is too bright, we can totally adjust that on the software to make sure that we have a clear vision on the sample. Like this. We can also adjust the focus stage or the Z stage. So I will adjust the focus to the sample a little bit more. And you can just double click on the position which you want to measure. Very simple. Like this. For example, I want to scan here, so just click here, and the XY style will be bring the tip to the Z location you selected. So we are done with the positioning. The next step is start the scanning. So firstly, we need to adjust the scan parameter. So I will select 256 pixels and 10 micrometer scan size with the average cutting speed factor. For the channels, I already preset the channels like amplitude, phase, height, and error signal for the NCM measurement. So we can click the image, and the tip will be approached onto the sample surface. And we can monitor that from this here. So this is the automation process. So we just need to monitor. So change the way, so we don't need to touch any hand. And after approaching, the scanning will be started. You can monitor the live updating line by line from this scan area and the scan traces. And you can see the forward and backward, which is the yellow and the blue lines, perfectly match to each other. So this means that we have the good tracking performance. And about the quality and speed factor, you can select either the speed priority or the quality priority depending on your target. So if you slide this one to the speed, the scan rate will be increased. However, the tracking performance sometimes is not really good depending on the roughness of the surface. And also you can select the high quality in which the scan rate will be decreased. It will take a little bit longer time, but we have the very good quality image. So to save the time, I will scan at a little bit high scan rate. The scanning will be updated line by line, and we can monitor that from this scan area. And this is the estimate type for the total measurement. So this is on about the auto mode. It's very simple. You just need to follow different like setup, precision, image, button. So if you click cancel, the current scanning area will be saved and the scanning will be stopped. And if we click end, the probe will be lifted from the sample surface. And after that, the laser beam will be turned off automatically. At this step, we can finish the measurement. So you can change to the new sample and restart the measurement from the precision imaging. So this is all about the auto mode. In the next, I will show you about the manual mode. So the user interface for the manual mode is a little bit complicated compared to the auto mode. This is more specialized for the expert user who want to control all the parameters in the scanning. So similarly, we have the vision doors here, and the base PD precision monitor here, and the scan area, server or the BIOS, you can control that. And also we have the scan area for the live monitoring of the scanning and scan traces window. So similarly, you can select the head mode to the one we want to measure. So I will go for NCM mode. The laser beam will be turned on automatically and automatically measurement for the resonant frequency. And the drive amplitude will be automatically tuned by the software. So you don't really need to care about the drive amplitude for the cantilever you're using because we already have that in the database. So the frequency sweep is done, and you can monitor the Q factor or the resonant frequency here. So I will close this frequency sweep window. And next, we need to adjust the scan area. Similarly, the pixel X and Y, scan size, offset, or rotation. Rotation means you can scan at different angle. Also, you can do that onto this here. So this large square box, 50 by 50 micrometer square, is the total scan region for the scanner. So you can just move like this. You can resize also, and you can even rotate that scan area. So once we are done with the scan area setup, we can approach the tip to the sample surface. So when we click approach, and the system will bring the tip onto the sample surface for the measurement. So at first, we need to monitor the light scan for the tracking performance of the tip. So you can see from the G height here and CM phase, we have amplitude and error signal. And as for the scan rate, you can either select the adaptive scan with a preset like quality and speed factor, or you can go for the fixed scan rate depending on your target measurement. So I will select the adaptive scan with the speed priority. Okay, and close that. And for the resolver here, you can adjust the set point manually. But the software already defined the optimal set point for this case, so I don't really need to change that. So, and also for the Z gain, I want to increase that a little bit for the better tracking performance. So everything seems okay, so we start the scanning. So all we need to do now is just wait for the scan to finish. And also from this manual mode, you can select the action after the scanning, like you can select lifting the tip automatically after the scanning finish, so that you don't need to wait until scanning finish and lift the tip off the surface by yourself. And also you can select the repeat scanning, in which the scan area, the tip will repeatedly scan continuously at the area you set. And also from this scan area, you can just freely move the offset for the scanning. For example, you can just drag the scan area like this, and the tip will move accordingly. And you can start another scan. And on the scan, image will be plotted here. So we can monitor like this picture here, and when we move to the next location, what is the surface structure? So we are done with the manual mode. The next one will be the step scan function. So I will select the step scan from this right hand side slide bar, step scan. And we can input different area as much as you want. So because we are on the surface, so I will lift the tip a little bit up. And go back to the step scan. So when we click this plus button, you record the current location of the XY stage. And you can select the scan mode. So I want to create a new one. And even we can copy on the parameter, on the optimized parameter from here into the step scan. So we just date it, and all the information will be copied exactly. And I will save this one into the contact mode. And then I want to scan one more area, so we'll move XY stage to the different location. And just need to add, and the current XY, current new XY coordinate will be recorded. And this one I want to scan also with the NCM. And for the knot, you can make the knot for the position. For example, this, let's see the center. And the second will be the top position. After finishing with the position setup, I will run the step scan function. So you can see it's moving back to the first XY coordinate and approach to the surface. And start the scanning. So when this scanning is finished, as I told you in the presentation, the tip will be lit from the surface, and XY state will move to the next location and approaching and imaging again. For example, if I cancel here, it will stop the scanning at the current location. And lift up the tip, move to the next location, approach again. Do the scanning. And this process will be repeated until on the position is finished with scanning. And you may need to select the lid when you finish. So after finishing, the tip will be lifted off from the surface so that you don't need to stick to the system during the entire scanning process. So this is all about the SmartScan demo. So let me summarize this webinar with a few benefits of the Spark SmartScan software. So we have the user-friendly interface that can provide you a new AFM using experience with a simple point-and-click action, like when you use the normal computer. And also the auto-imaging mode in combination with the adaptive scan function, the True Non-Contact mode, and the step scan can reduce the struggling with the trial and error approach to get the AFM image. And this is helpful for all users from the beginner to the expert level. So this is the end of today's webinar. Thank you very much for your attention. If you have any questions or comments, please feel free to tell me. Thank you.
Okay, thank you very much, Dr. Rocky Nguyen. So, dear audience, if you have any questions, feel free to type in the chat section. We'll go through the questions later on. Okay, Dr. Rocky is on the line. So we have a few questions coming in. Right. So the first question from the audience is how can we calculate the grain size by using AFM?
So for the grain size, we have the AFM data analysis software. We call that XEI. So that is a separated software from the SmartScan you saw, and that will allow you to calculate on the parameters like dimension or scan size or everything.
Okay, seems like there is no more questions. So, audience and attendees for this webinar session, if let's say you have any other questions for AFM related, feel free to contact us. We will get back to you as soon as possible. So that's all for today's session, and have a good evening. Thank you very much, and bye bye.
Yep.